what was the topic that we have? What was the topic that we discussed in the last session? We didn't go very in deep into the concepts of Docker and Kubernetes. I just gave you a small glimpse about the concept. So can anybody tell me what we have covered in the last session? Who is attending to this session? The person who is attending to the session from the last session. Anyone there? Go on, guys. What did, if anybody attended from the last session, can you please tell me what is your understanding towards the previous session so that I can go into the main concept of the next session? I mean, main concept today.
In last section, you have explained about the Dockers and what is the use of the Docker, how you are building the Docker containers. You have explained that regarding that one.
Okay, so we got to know about what is meant by Docker, what is meant by a container, and how we can create a container, but not very in deep about the containers, right? So let's discuss about the containers. So to understand the containers first of all, you need to understand the Docker. I'm just going to repeat it one more time so that you will get a clarity about what is meant by Docker here. So let me,
Chaitanya, this is Avinash. Like I joined today. Like I think I've missed out yesterday's demo. So today is my first day. Just telling you.
I understand that. So don't worry. So you will understand totally. We did not discuss very in deep about the concepts yesterday. Okay. So just let us go with a small flow here. So in the olden days, if you go back to the olden days, what has to be done? So we will be having a server. So just go back to some 20 years back. Just go back to 20 years. So you are having a server. In this server, we will be having an operating system. So the server will be of somewhere like 16 CPU, and 256 GB of RAM, and then somewhere like 256 GB of RAM, and somewhere like I can have some 1 TB of SSD or else storage. So simply I will call it as storage. So at that particular time, we don't have the SSDs. So 1 terabyte size of storage is there. So inside this, what we will be running an operating system. So just for an example, it's a Linux operating system. Let us take it like this. So in this Linux operating system, I am already having an application running. So there is an application which is already running, and this application is running on, for example, Java 1.8. So the application is running on the Java 1.8. Okay. And then we are having I want to create a new application. So I am creating a new application on my desktop. So this is my desktop. Inside the desktop, what I can do, I can create my new application with all the requirements. But whatever the new application that I am creating here, it is Java 11. So I'm creating this application on Java 11 dependency. So this is my, for example, I will make it as app-1.1. So this is app version 1.1. So whatever the application that we are previously running, this is app version 1.0. So now whatever the application that we are having, app version 1.1. Okay. So now if I want to run this application, whatever the application that we have created, if I want to run this application in this server, is it possible to run that application? Is it possible to run the application?
Yes, it is possible.
How?
You can have 2 instances of Java and you can deploy your application separately.
2 instances means 2 different servers, huh?
No, within the same server, we can run multiple Java instances.
Now we are having, but if you go back to some 10 years back, then
even then, we can still install.
You are saying that, okay, that's fine. So you are saying that we can have 2 instances and we can run. That is fine. So now when I run Java, first of all, I will install Java 8 and I will run the Java 8 application. Okay. And then what I have to do, I need to change it back to Java version 11. So I will install Java version 11. And with the help of this one called as Java runtime configuration, we are going to upgrade that to Java 11. So, and then I will start the Java 11 application. It will be running. So now when they are running, this is fine. But my question is whether the Java 8 application will still run.
I mean, technically, it is possible to have JDK 8 and JDK 11 to run on the same.
I totally understand. I totally understand. But if you are having these many number of things, there will be a compatibility issues. Okay.
Yes.
So this compatibility issue, whichever we are facing here, so to overcome this, what I have to do here. So we are having, and not only this, I can run multiple applications inside the same server. Now what I want to do here, so from this particular single server, we are moving into a concept called as virtual machines. Why we are moving into the concept called as virtual machines? The whatever the server CPU and RAM that we are having, that is huge. But the application requires only, for example, this application might require maximum of 2 CPU and some 8 GB of RAM. And this application might require some another like 2 CPU or 4 CPU and some 32 GB of RAM. In the maximum cases, 32 GB of RAM. And I think you know about all the concepts like Java. At the starting of a Java application, definitely it is going to require huge amount of RAM. So everyone knows about that, right? So any which ways, so now what is happening here? So whatever the application at the initial stages, it is requiring the huge amount of resources, but after that, it is not requiring more resources. And as well as when the load is there, then only they are requesting some huge resources. If the load is not there, then they are not requesting. So now what is happening here, whatever the server that we are creating, that we have right now, whatever the huge instance that we are using right now, we don't have anything like precisely I can say that this complete instances or else complete resources are going to be consumed by the application. Optimization is happening with the server. I cannot say that optimization in the sense the resources, at least 80% of resources are consumed by the application. I cannot say that. So a lot of resources are getting wasted. So to overcome this problem, what IT industry has decided here is they have developed a new concept called as virtualization. Whatever the servers that you are having, so the entire physical hardware is taken into a single, the entire physical hardware like 16 CPU and some 256 GB of RAM is considered. This is the physical hardware which you are having. On the top of that, we are going to install a virtualization software. So VMware ESXi or else hypervisor in Windows or else Citrix that we are going to install. So for example, I will take VMware ESXi. VMware ESXi. So this is the VMware virtualization software which I am going to use. Inside this, what I can do here is I can create some virtual machines. So these are as it is like your servers itself, but they are virtual. Okay, so for example, if I have to tell you, you have a hard disk. Hard disk is a physical entity. You can touch and feel it. But inside the hard disk, what you are doing, you are dividing the hard disk into small partitions. You are dividing the hard disk into small partitions, which are the logical way of divisioning. So which are the logical way of divisioning in the sense, so whatever the C drive is there, you are not going to break your hard disk physically and make it like 1 GB of or also some 100 GB of storage for your C drive and 100 GB of storage for D drive. You are not going to physically break the hard disk. You are logically breaking the hard disk, or else you are logically dividing the hard disk into small portions. Here also what we are doing with the help of virtualization software, we are dividing or else we are logically creating the virtual machines. So this is my VM1, virtual machine 1. And inside this virtual machine 1, so from where it is going to get the resources, the virtual machines are going to get the resources from the physical server only. Wherever you are having, whatever the physical server resources are there. These resources will be given to your virtual machines. So inside the virtual machine 1, I am going to install the guest operating system. So here I can install the guest OS. Guest OS. And inside the guest OS, I can run the dependencies, whatever it might be, Java, .NET, Python, any dependency I am going to install. And inside that I am going to, I can run my application. So this is what going to happen. So I can create one more virtual machine over here. So this is the virtual machine 2. So this virtual machine also getting the resources from the physical server itself. Physical resources are going to be given to this virtual machine 2. And then what is going to happen here? VM2. So inside this, we will have a guest OS. Inside this, we will have the guest OS. And for example, here I can install a Red Hat Linux. So here I can install the Ubuntu, and other guest OS will be a Red Hat Linux. Inside that I can run my application. So this can be done. So this is my guest OS, which I am going to install on the virtual machine 2. Inside that I can run the application, which is a Python application. For example, Python app. This I can run. Like that, we can create multiple virtual machines from this physical. So what is happening here, whenever the virtual machines are getting created, the total resources of your server are going to be consumed. That is what my requirement. So if I see, if you purchase a bike, or else if you purchase a car, if you don't use it to up to the maximum potential, then there is no necessity of purchasing anything, right? So I want to use this for the maximum potential, for its maximum potential. For that, what I have to do, so to overcome this problem, or the problem that you are facing in the physical server, I want to overcome that problem. For that, what I'm doing here, I am going to go for the virtual machines. So what are the problems that we can overcome with this means? We can overcome with multiple problems, like you cannot have a single instance. You can have the multiple virtual machine instances. For the cloud that we are using right now, AWS, whatever the EC2 instances that you are seeing, Azure, whatever the virtual machines that you are seeing, those are all the virtual machines which are generated from this servers itself. So these servers are available, and from the servers, what you can do, you can access your virtual machines. Now, what is the problem in this virtual machine concept? Everything is fine, no? So then why we are going for the Docker and containerization platform? What is the necessity of Docker and containers? So we are going with the Docker and containers because, for example, what I can tell you, why we are going for the Docker and containers means, so inside this guest operating system, whatever the guest operating system that you are installing, how much amount of, what will be the size of that particular guest operating system? So at the time of installation, when you see in your hard disk, what will be the size of that particular guest operating system? Anyone, did anyone checked out what is the size of an operating system? It will be somewhere like some 20 GB of size will be there. Okay. Why it is 20 GB of size? Did anybody checked it out? So whatever the Windows operating system right now I am having in my C drive, it is occupying somewhere like some 100 GB of space. Why this Windows operating system is occupying some 100 GB of space? What is the necessity? Why it is happening like that? Did anybody question, or did anybody checked out? Yes or no? I don't want anyone sitting calmly. Do you understand my question or not, at least?
Yes, we have checked because it depends upon the libraries and the systems. It is day by day it is growing on as the patches, updates, and everything. The sizes has been increased.
Okay, so that is why the size has been increased. Okay. So to run the application, do you really require all the, whatever the applications that are installed on the operating system, is it really required to run an application? Why you are having a server? First of all, tell me that. Why you want a server? Or else why you want a machine?
To host any of the websites or applications.
To run the applications. Okay. So to run the application, we need the servers. And if we want the servers, definitely we need to install the operating system. When we install the operating system, what is going to happen? All the unnecessary software is going to be installed. Yes or no? So of course, there will be something necessary softwares will be there, but apart from that, we are going to have some unnecessary softwares also be there. So which will increase the size of the particular operating system. So now if I want to move that machine, whatever the operating system installed machine is there with the application, I want to move it from the production or else from one environment to the another environment. So how much amount of data I have to transfer? Just for an example, if you can say.
It's a minimum 50 to 100 GB.
50 to 100 GB of, don't go for 50 to 100 GB. Let us take some 20 GB, a minimum of 20 GB I have to transfer from development environment to the production environment. To transfer 20 GB, it is going to take some time, like some 15 to 20 minutes, or else sometimes it might be going beyond that. So this is one of the main problems. So migrating from one environment to the another environment has become very, very difficult when you are using the virtual machines. So how we can overcome this problem? To overcome this problem, we are going for an application called as containerization platform, which we are using as a Docker. Inside that, we are going to create the containers, which will be having only the necessary binaries and libraries. Inside the containers, we are not going to install any sort of operating system. We will be using an image, and with the help of that image, inside the image, you will have only the libraries and binaries which are helpful for you to run the application. So apart from that, you don't have anything. So that's why the containers are lightweighted processes inside the Docker environment. Containers are the lightweight processes inside the Docker environment, which will run only the application and its dependencies. Apart from that, they are not going to run any sort of unwanted applications. So when you see that, that is the reason. So when you, if I'm running a Docker application, automatically the size of that particular Docker application or else the Docker container will be somewhere like 70 MB, like that you will see. So just let me show you about that. So when I go back here, I will log into my AWS environment. In the AWS environment, what I can do here is, let me go back to North Virginia location. Here I already have a Docker server. This is what we have discussed in the last session also. Don't worry who has optioned for the last session. Don't worry that I discussed something very, very in detail. So the same concept I have discussed. I'm going to start an instance over here. Now, if you can see, let me log on to the instance. Okay. When I log into this instance, okay, so this is the server. Inside the server, I already have my Docker. Okay, Docker is there. Now, Docker images. Now, when you see what is the size of this Ubuntu image, the size of the Ubuntu image is only 78.1 MB, which is of 24.04, and this is the second version. 22.04 is only 77.9 MB. So not much difference is there. So which is equivalent to 78 MB. Both are 78 MB size only. With that, I can run a container. Docker run -itd -name. Don't worry, I will tell you about this command, but basically I'm showing you how to create the container. Ubuntu container, and with the image Ubuntu version 24.04. When you see here, we have the container created. So this is the container. So inside the container, if I go inside the container, Docker execute -it, Ubuntu container and bash. Right now I am inside the server. When I try to go inside the container. Now I am inside the container. Here you can see root @ IP 1023.18. So this is the server IP and this is my container ID. So I am just logged into my container. So once I have logged into the container, no basic utilities will be there. So at least ping, we can guess that there should be ping. So ping will also be not there. So when I go for google.com, ping is not there. And I want to know the IP address of this container. If config is not there, nothing, no utilities will be there. Only the environment and the basic utilities which are required. So those will be available. Apart from that, nothing will be available. Only the binaries and libraries and the environment for your Ubuntu that will be available inside the container. Now, whatever you want to create, you can create from the scratch. So if you want to create a Java application, you have to create it with the basic Java configurations and Maven thing, and then you have to run the application. So only the application and dependencies are going to be installed. Apart from that, nothing is going to be installed in your container configuration. So this way, the containers are very easy to migrate, and as well as the images will be very easy to migrate from one location to the another location. Here we are not going to migrate the container unless we are going to migrate the, we are going to migrate the images. So from one environment to the another environment, simply we are going to migrate the images, and from those images we can run the containers in any location. So this is about container configurations. So that's why we are going with the Docker containers. Okay, so that is the reason why we are going for the Docker containers. Now, here you have to understand one thing. Now, what is a container? What is a container? So from the last 15 minutes, I am saying you about the container. No. So what did you understand? What is meant by a container? We came across the physical servers, virtual machines. Now we are discussing about the containers. So Docker, in the sense, the main concept of Docker is containers only. We are discussing only about the containers. Docker is just an application which will host the containers. Now, what is meant by a container? What did you understand from last 15-20 minutes which we are discussing? Tell me, guys. What is your understanding?
A package of applications which is executed on a system.
Okay. So a container is a package of applications which will be running on a certain certain system. That is what you are saying. Okay, this is fine. Any another? Any another person? Can you tell me what is meant by a container?
It runs the application and only the necessary dependencies needed.
Yeah, a container is a container will have the application and its dependency. Okay, you are saying what will be present inside the container. Now, nobody is saying about what is meant by a container. So now a container is a process in an operating system which will have the application and its dependency. Now, what does this process means? So ps-ef, this is the command which we will be using to know what are the running process in an operating system, especially in the Linux operating system. When you see here, we are having so many processes that are running. So now what I am trying to explain you here, tmux, it's a terminal multiplexer, guys. So what is meant by tmux means? Tmux means terminal multiplexer. So which is going to divide the terminal into multiple terminals. So here you can see Control B, Shift double quotes. So now the terminal has been divided into two terminals. Control B up arrow, watch-n1, ps-ef, grep container, grep container. When I give this command, here you need to understand one thing. Control B down arrow, Docker ps. So we have a container running. What is the container ID? C729D24. Here you can see C729D2. So which means that this is the process within the Linux environment. A process is running, and that process we are calling it as a container. So now if I come down, and what I can do, Docker stop C7, I will give the container ID. So let me copy this. I'll give it over here. So this is the container process which is running. So when I give this, so look at here, what is going to happen. So this 1200 is the process of your container. So when I press enter, so hold on. That process should be terminated. So look at that. The 1200 process got deleted. Why? The container is stopped over here. When I start the container again, docker start. When I start the container again, what is going to happen? Here you can see another process is created. So which means that what you can say here, a container is a process running in an operating system which can run the application and its dependencies. So it's simple. So for example, if you are having a Google Chrome, so what is this Google Chrome? Google Chrome is an application inside a Windows operating system. Google Chrome is an application inside the Windows operating system. Application is nothing but a process. So inside the Google Chrome, we are going to access only one website? Inside the Google Chrome, we are going to access only one website? So here I can use Amazon AWS website, and then I can go for Amazon.com. So this is my e-commerce website. Again, I can go for what else? Geekforgeeks.com. Okay, so this is one more website I can access. And then what I can do, I can go with somewhere like Flipkart.com. So this application I can open, and I can go open the portal.azure.com. So on the Chrome application, I am opening multiple processes. On the Chrome application, I am using AWS is one of the web application, and then Amazon.com is another web application. Geeks for Geeks is another web application. Azure is another web application. Like that, what is happening? Everything. So whenever we are working with, so this Google Chrome itself, what is happening? We are having a single application. Inside the single application, we are running the multiple processes in multiple tabs. Okay, in the same manner, in your operating system also. So whenever we are creating a docker application, there will be the hardware. On the top of the hardware, you will be having the operating system. Here we are going to create a Docker application, just like your Google Chrome. On the Docker application, I'm just going to run my container. So this is one of the process, just like how I have opened the AWS is one of the tab. In the same manner, here also I can run one of the container, and this container I can run the Java application. How I have opened another process called as Flipkart. So that is another process which is running inside your Google Chrome. In the same manner, in the Docker also, I can create one more container which will be running an Python application, and then I can open portal.azure.com. So this is another tab which I have opened in the Google Chrome. In the same manner, in the Docker also, I can create one more container which will be running the application of .NET. So like that, I can run multiple containers of different environments in a single application called as Docker. So Docker is going to host all your containers. So whatever the Docker that we are thinking right now, Docker is just an application which is going to host your containers. So inside the containers, your actual application will be running. So inside the container 1, I can run a Java application. Inside container 2, I can install the dependencies for Python, and I can run the Python application. Inside container 3, what is going to happen? One second. Inside container 3, I can install the .NET application, and I can run that particular application. Container 2, here I can run the Python app. In container 3, I can create .NET application. Container 3, .NET. So here these containers doesn't have any connection with the host operating system, whatever the Windows operating system that you are running, or else Linux operating system, host OS. So when they will be requiring this host operating system. So whatever the Java application that they want to run, they require certain CPU and RAM. So this container will communicate with the Docker, and Docker will communicate with the host OS, and the host OS will communicate with your hardware. This is what going to happen here. And the hardware will provide the required resources for my container. And as it is, the same configuration will be happen with the container 2 and container 3 also. So the containers will communicate with the Docker, and Docker will communicate with the host operating system, and host operating system will communicate with your hardware to provide the resources for the containers. So this is the concept of your Docker and containers. Okay. This is about your Docker and containers. Any questions from this concept? Do you understand what is meant by a container? Can you explain what is a container? Container is a process which will have the application and its dependencies, which will run the application and its dependencies. Which will run the applications and its dependencies. So this is called as container. Okay. So now you understand what is meant by a container. Now, how this containers came into the picture. So for every invention, there should be how. So how the container has created, what is the base for creating this container, what is the idea, what is the thought behind generating the containers. So there will be everywhere, I mean, for every invention, there should be a how concept is there. Now, how these containers are designed. So now, when you go back to the Linux operating system, in Linux operating system, latest Linux operating system, there are two features that are incorporated. One is C groups, and the other one is namespaces. So what is the C groups? C groups means control groups. So to provide the control over CPU and RAM. So when the container is created, or else when a process is created, that process should not capture more amount of CPU and RAM. Okay, so for example, there is a process running. There is Google Chrome is running. The Chrome should not consume lots of CPU and RAM. So to overcome that, we can go for a control groups configuration. So, and the next one is namespaces. Namespaces in the sense, now here you can see, we are having a lot of process in the Linux environment. Here you can see. So how these processes are divided? Processes are divided depending on the namespace called as process IDs. Here you can see these are the process IDs of different process. So each process will be divided based on the process ID. That is one thing. And the second one is, for example, inside the server, for example, let us assume that inside a server, we are having the multiple applications are running. If we are having the multiple applications that are running, can I expose all the application on a single port number? Is it possible to expose all this application on a single port number? Port number is the entry and exit point for the application. So this is app 1 and this is app 2. For example, if any customer want to communicate with app 1, if any customer wants to communicate with app 1, can I create a single port for both the application, whether they will accept it?
No.
No. So definitely we need to have the different port numbers for each and every application. If we are having a single port number, then first of all, we are going to get a conflict. Already the application is running on that particular specified port number. So you have to choose another port number. Like that, we are going to get an error. So now, depending on the port number, depending on the network also, we are dividing the services, or else we are dividing the processes. So namespaces are defined depending on the process ID. And then, so the scientist understood that, okay, there is a concept called as namespace where each and every application is divided either depending on the process ID or else depending on the network configuration. So like that, they have understood. Okay, so now this is a concept called as namespace, where each process will have its own process ID and the network configuration. And if these processes, whatever the processes that are running in your Linux operating system, if these processes can be controlled the CPU and RAM utilization can be controlled, then we can create certain concept called as container. So based on this namespace and control groups of your Linux operating system, whatever the features that are defined, depending on that, the containers has been evolved. So if you want to understand this, let me go back here. What exactly is a container? So if you can see, what even is a container? Namespaces and C groups. So now if you see here, first I heard about the containers, it was like what and what's that? Is a container a process? Yes, it's a process. What's Docker or the containers Docker? So container is not a Docker, guys. Docker is an application which will host the containers. So there is a lot of difference between container and Docker. Now, if you come here, the word container doesn't mean anything super precise. Basically, they are a few Linux kernel features. So basically, the containers are evolved from a few basic Linux features called as namespaces and C groups that let you isolate the process from each other. This is what we have discussed. Each and every process will be an isolated element. Each process will have its own process ID. So when you use those features, you can call it as a containers. When these two features are came into the picture, then they are called as containers. Basically, these features let you pretend you have something like virtual machine, except it is not a virtual machine at all. It's just a process running in the same Linux kernel. So it is just a process. That is what I have shown you by taking this example. Whenever I run the container, automatically a new process is generated. If I stop the container, the process got terminated. Now, when you come down, namespaces. So let's say we wanted to have something like virtual machine. One feature you might want is my process should be separated from the another process on the computer. So if two applications are running, there should not be any interconnection between these two applications. They should be in an isolated environment. So one feature Linux provides here is namespaces. There are a bunch of different kinds like PID. Like I said, process ID can differentiate the processes and the network namespace and storage. These are all the features that will divide the processes. And if you come down here, there is a concept called as C groups. So now what is meant by C groups? C groups means we have made a new magical world with the new processes and socket that is separated from the old world. So what if you want to limit how much of memory or CPU one of my program is using? For example, I want to run a Java application inside a container. So when I run a Java application, it should not consume the entire CPU and RAM. So it has to consume only a limited specified resources only. To do so, we are going to have with this C group. Okay. So then we are going with the control group so that we can adjust that. With the help of this, what we can have here, so nothing but the containers. Okay, now you have seen the two features, you might think I can build a bunch of scripts around all these features and have something really cool. It would be really lightweight and my process would be isolated from each other. So then that's called as a container. Some people thought that in the past too. So they built a thing called as Docker containers. So whatever the features that I have specified, like namespaces and the C groups, depending on these two things, the Docker containers has been evolved. So if I have to define what is meant by a Docker container or else what is meant by a container is a process running in an operating system which will be having or else which will run the application and the application dependencies. So these containers are isolated from the another container. Whatever the first container I have created, the first container and second container doesn't share anything. So they are just like two different computers running on a single network. Okay, so that is what I call it as a container. Okay, now you understand what is meant by a container. Any questions here?
No, it's
Any questions related to the containers? Is it clear for everyone? Do you find something jargons I have used or else something difficult pronunciations I have done? Do you find like that, or are you comfortable with the language? You can express your feeling.
I have a question.
Yes.
So you'll talk about C groups. So C groups are to compartmentalize memory, right? I mean, storage and memory. Is that pretty much what it does for C groups?
Exactly. Control groups are going to limit your container CPU and RAM. How much amount of CPU that the container has to use, how much amount of RAM that the container has to use, that can be defined with the help of C groups.
Okay, and then the namespaces it allows you to separate out the
processes.
what processes? Okay. All right, cool. Thank you.
Namespaces are used for separating the processes. Here, processes are nothing but the containers. Okay.
One
Okay,
question.
thank you.
Yep.
Yeah.
Tell
So
me.
the namespaces, what we are talking about here is purely related from the Linux kernel primitive, not the namespaces of Kubernetes, right?
No, it is not the namespace of Kubernetes. That is totally different concept. This is totally different. This is
So
a kernel-based namespace which we are discussing here.
Okay.
Okay, right. Anything else, guys? Okay. So here I will stop today's session. So what are the topics that we are going to cover in the entire sessions? Let us discuss about that. What is the duration? What will be the timings? So let's see about that. So the duration will be 25 days. I will make it as 25 days, 20 to 25 days mostly. And the next one is here we are going to cover Docker and Kubernetes. And the next one is timings. I'm really sorry, I cannot adjust the timings. The timings will be 6 p.m. to 6 p.m. IST to 7:30 p.m. IST. So why? Because I already have a session which is running from 4:30 p.m. So the Terraform, Docker, and Kubernetes session, which is already running in the 4:30 p.m. So it is about to, we are about to start the Docker and Kubernetes in that session also. So it is a little bit difficult to change the timings. So please accept this. And if anybody are interested to join the Docker and Kubernetes sessions, no, but that's okay. So it will take, like, we are going with the Terraform itself. We are in the middle of Terraform. So it will take another 1 week. So sorry about that, but these are the timings. And the next one is, what else? Yeah, syllabus. Syllabus will be Docker. In Docker, we are going to discuss about Docker basics. In Docker basics, we are going to cover the containers, which we have discussed right now. Containers, and then Docker container architecture. And then we will discuss about container lifecycle. Container lifecycle. And the next one is Docker networking. And then Docker images with the help of containers. How to generate the Docker images with the help of containers and with the help of Docker file. Docker file. And the next one is Docker volumes and the Docker compose and Docker swarm. These are the concepts that we are going to cover here. Here in the images, we can check out the multi-stage Docker file also. So this is about what we are going to discuss here. And the next one is Kubernetes. In Kubernetes, we are going to discuss about K8s architecture. And then we will be discussing about creating K8s cluster with kubeadmin, KOps, Kubernetes operations, Rancher, and AWS EKS cluster. So these two I will tell you in the at the end of your course. But kubeadmin, and with the help of kubeadmin and KOps, how we can create, I will tell you in the beginning itself. And the next one is workload components and services, probes, sidecar containers, namespaces. These namespaces are different. Kubernetes namespaces are different. Namespaces and resource quotas, Then we will be discussing about advanced scheduling. Advanced scheduling, where we are going to discuss about node selector, node affinity, taints and tolerations, and then pod affinity and pod anti-affinity. These we will be discussing in the advanced scheduling. And later we will be discussing about RBAC, role-based access control, storage. In storage, we will be discussing about empty directory, and then we will be discussing about persistent volumes, persistent volume claims, and EBS volumes, and EFS configuration, storage classes, and we'll be discussing about dynamic provisioning, dynamic storage provisioning. So these we will be discussing in the storage, and later, did I miss anything? Okay, we'll be discussing about secrets and config map, secrets and config maps. And then we'll be discussing about the next concept is network policies. And then we'll be discussing about Helm, and then HPA and VPA, horizontal pod autoscaler and vertical pod autoscaler. Then we will be discussing about STO service mesh. And then we'll be discussing about GitOps. GitOps called as Argo CD. And finally, AWS EKS configuration. And we'll see a mini project kind of thing. So these are the things that we are going to cover in the entire Docker and Kubernetes sessions. Okay. So that's about the syllabus. Am I clear with this?
Yes.
Yes. Are you going to cover any real-time scenarios like real-time?
Everything we are going to discuss in the real time itself. Okay. Here, if I would have said you in the mini cube, okay, but we are going to create the Kubernetes cluster directly. Okay. So which will be we will be discussing everything in the real time itself.
Are you going to discuss about YAML?
That is what manifest files. We have to know about the YML file, YML configuration.
Okay.
Without
Can you think of Terraform also? Yesterday I have discussed this one. I have discussed with your person also. He told that he will check with you and update us.
Let me check with them. So I didn't get any call. So I have to check with them and I will let you know.
Okay.
Terraform. Okay, no problem. So just give me some time. I will let you know about that.
Okay.
Right.
One question, like where do we actually practice all these things? Like, do you suggest us to take our own cloud accounts?
We are going to have this on the AWS environment. Definitely, you need to have an AWS environment.
Okay. Okay.
So my forgot about the prerequisites. So basic knowledge on AWS. Why? Because we are going to discuss everything on the AWS environment. So if you have the basic knowledge, that will be very handy for me to go ahead into the concept very easily. Okay. So if you don't have an AWS account, please take an AWS account. That would be an added advantage for you.
Okay.
Anything else?
Yeah, I had a question for you.
Yep.
I know you had mentioned I was the one who mentioned about the earlier time, but you had mentioned that you had another course that you were teaching for this on Kubernetes and Terraform. Is that still running, or is that a
It is about to start somewhere at 4:30 p.m. But currently we are into the Terraform configurations. So another 3 to 4 days it will take to complete Terraform, and then we can jump onto the Docker and Kubernetes.
how long has the session been going on for?
From
When did it
4:30 p.m. IST to 6 p.m. IST.
Okay. Would I be able to get some information on that batch?
Definitely. You just need to contact DURGASOFT related to that, so they will provide you as much information like. So currently,
Okay.
right now, I'm not. Okay, I mean, I'm not allowed to speak that, but any which ways, you can just
Understood.
contact them. They will provide you the consent details for that. Okay.
Okay. Thank you.
Right. Anything else, guys? Okay, fine. So that's it from my end. Have a nice day, and we'll meet in the next session. Next session will be very, very interesting session where we are going to create the Docker. So as per you, maybe these are the demos as per your concern. I mean, as per your way of thinking, these might be the demos. But for my way of thinking, these are the classes that we already started from day one onwards itself. These are the directly we are jumping onto the sessions itself. Okay, we don't have anything we are going to have another few demos and later we will join into the sessions. No, it is not like that. We will be directly onto the sessions itself. Okay, so yes, and tomorrow will be the final demo for you. So the third demo, that's the final demo, and then from Thursday onwards you will have the sessions which you need to get a premium link. So from there you can join the sessions. So have a nice day and we'll meet in the next session. Bye guys.
Yeah,
Thank you all.
you.
Thank you. Thank you.